Hello, and this time we're looking at how to draw a histogram. And if you're thinking, wait, what's a histogram? Well, I will go through that first. So here we have a table of data. We've got a set of times from 0 to 3, 3 to 4, and 4 to 8. And we've got how many things happen in that time. And we've drawn a nice bar chart here. I mean, looks delightful. We've got huge towers for the 0 to 3 minutes, an even big one for the 4 to 8, and then not much happened in the 3 to 4 minutes. But actually, this is an appalling graph. We do not like this because actually, yes, these bars are bigger, taller, that more happened, but they had more chance. Yes, this had 3 whole minutes to collect 15, and actually the fact that that's almost like, 5 a minute, whereas this managed to get 9 in a minute. And although these managed to get 16 in 4 minutes, that's only like 4 a minute. So it's making these two bars look amazing. They're so tall and massive. And this looks like, that's the insignificant bit. Not much happened in the middle. Well, actually, no, lots of stuff happened in that middle minute, in that 3 to 4. This is the important one. And the way we've drawn the graph is confusing that. And the issue is that you should never, ever draw a bar chart if the widths of your groups is not equal, because it's misleading. We as humans look at this and we see this area and we say, oh, look, that's a huge amount of area, that's the most important bar. Whereas actually, as I've said, this had the most dense amount of calls in it, so surely this one's important, but we've been confused by how it's been drawn. So a histogram is like a better version of a bar chart that addresses this issue. And what we do is, instead of plotting frequency, instead of making the height of the bar proportional to how much stuff we've got, we're going to make the area of the bar proportional to how much stuff we've got. And that's frequency density. Frequency density, or FD for short, is worked out as the frequency divided by the class width, or CW for short. The class width is just how wide is the little range here. So here it's 3, there it's 1, and there it's 4. And if we draw this instead, we get a much better picture. Here it is. So let's just see how we did that. That's the end result. So what I would first do here is put a column for width. So we've got 0 to 3 is 3, 3 to 4 is 1, and 4 to 8 is 4. And then frequency density is the frequency, put that back on the screen, frequency density is the frequency divided by the class width. So 15 divided by 3 is 5, 9 divided by 1 is 9, 16 divided by 4 is 4. Now, you often get decimals in this, so don't worry if you get really horrible decimal numbers. That's absolutely normal. It just happens in this case. They've done nice, easy numbers, and we haven't. And here's the picture. Now, I still draw the bar between 0 and 3. I still have just a normal axis for x and y. And because this is the 0 to 3 bar, it's drawn out from 0 to 3. But it's only drawn 5 high, because that's the frequency density. This 3 to 4 is drawn 9 high, and this one's drawn 4 high. So you can still see that there's more stuff here. This is a bigger chunk, okay? It looks like there are more calls here, and indeed this is a bigger piece than this, because we're looking at the area and thinking, yeah, that is more stuff than in here, and that's true. We're not trying to hide that. There are more calls in this block, but the point is that there are more calls, but it was spread over longer, and that's why the histogram has shrunk that down by making its area 15 rather than its height 15, so that you can see that yes, this is a peak. If we had done all of these minutes separately, we would not have it like the original picture. We'd have this sort of getting more and getting less. Now, I don't have enough information to say that yes, it's definitely that we would have had that many, then that many, then that many. I'm not saying that we can say it's this nice even distribution from just 3 data points, but what you can see is that middle one is the important one, and that's why we draw histograms, by working out the widths, working out the frequency density, frequency divided by width, and plotting that against the whatever the variable is. In this case, it's a duration of calls, so it's time in minutes. Okay, What can you do with histograms? Well, I'll make another video that goes into that, but just so that you're aware, if you're asked, how many people took longer than 4 minutes, well, then it's this many people. If it says estimate how many people were on more than 6, then you can say, well, it's this many people, and you can either just do it back. You can say frequency is density times class width. So the density is 4, just reading that off. The width, the new width, because I just want a smaller block, is 2, and you can multiply that together to get that. Or you can look at this and say, I know that this area is 16, so each square is 1. I've got 1, 2, 3, 4, 5, 6, 7, 8 squares. So it doesn't matter whether you look at it as an area problem or if you just rearrange that and turn it back. But you can do that. You might also be asked to find the mean for this. Well, if you're given the table, then it's nothing to do with histograms. You're just going to do the midpoint times the frequency, times those together, add it all up, divide by the total frequency. This will be in another video that I've done in the past, if this is too quick for you. And then if you've been given the histogram and asked for the mean, you can still do it. It's just that you have to use the density and the class width to work out the frequency, and then you can process it like before. If you have any comments or questions, then you can pop those down below. But otherwise, cheerio.